Sorry. Yeah, here we can code equivalent fraction.
And equivalent fraction is like if I have 3 upon 4, I will multiply both of them with the same number, and yeah, and that is an equivalent fraction.
Correct. Guess what? Do you have anything to say about equivalent fraction?
Yeah. The simplest form is the. Wait, how do I put this in words? A by B. No, okay, I can't put it in words. I have to think. Wait.
Okay, put it in numbers.
Could you,
Put it in words. Put it in
EP, could you, EP, could you write
Okay,
equivalent?
what happened?
let's say you have 12 by 36. So
Okay.
you have to find the highest common divisor or the greatest common, whatever, man. The
Okay.
highest common factor, and then you divide them both with the same number.
Yes.
And the answer which comes is the simplest form of that fraction.
Correct.
This is equivalent fractions.
Okay, the simplest form is also equivalent to 12 by 36. Okay, correct.
Yeah.
Let me start by giving my examples. So, one of the example I would say is 1 by 2, 5 by 10, 3 by 6, or say 500 by 1000. So, all of this is equivalent fraction, right? So, basically, if you have a cake, make it into two parts and eat one part. That is going to be same as cutting the cake into 10 parts and eating 5 of it. Cutting the cake into 6 parts and eating 3 of it. Right? Basically, you would end up eating the same amount of cake in either piece.
7.5 by 15.
Right? In whatever case it is, you will be ending up eating the same amount of cake. So equivalent fraction is doesn't matter how many partitions you make. In this case, you are making 2 partitions, but you are eating 1. In this case, you are making 10 partitions, but you are eating 5. In this case, you are making 6 partitions, but you are eating 3. Right? So 1 is half of 2, 5 is half of 10, 3 is half of 6, 500 is half of 1000. Basically, all of this is going to be equal to half of something. Right? All of this is half of something. So all of the equivalent fraction of all this fraction is 1/2. So if you are clear with this concept, then you know the concept of proportionals. Let me see how. So let's say we are making a lemon juice. For lemon juice, we need 1 lemon so or let's say not 1 lemon, half lemon, 1 lemon for 2 glasses of water. Okay. I need 1 lemon for 2 glasses of water. Then how many lemons do I need to make 10 glasses of water?
I.
Yeah. So
10 lemons.
yeah, so in this case, 5 lemons, correct. We need 5 lemons to make 10 glasses of water.
You said 20 glasses of water, no?
20 glasses.
Acha, you said 10.
1 lemon, 2 glasses. Right, so 5 lemon, 10 glasses. Okay, then for 20 glasses, how many lemons do you need? For 20 glasses, how many lemons do you need?
10 lemons.
Arey, I thought you asked for 20 glasses, how many lemons?
Oh, did I say that? Oh, sorry, but I wrote 10 glasses. Okay. So, this is what is proportion actually. So, you know something, with the idea of what you know, we can extend it. We can extend it to something else. So, we know that for 1 lemon, we have to make 2 glasses of water. So, if I am asking you for 100 lemons, how many glasses of water do we need?
200.
200.
200.
Basically, with what we know, this is what we know. What we know. With the idea of what we know, we will be determining. What is determining? We will find it out. We will determine extended to 10 glasses. So from what we know, we can determine what we don't know. Yes, Priya, what is it?
Akka, you are in the 100 upon lemons, you've written 200 upon lemons, and it's supposed to be
Sorry.
200 glasses.
It has 200 glasses. Thank you. So for 100 lemons, we need 200 glasses of water. Yeah, so now here is pointed out something very important. If you see this particular thing, what we write is very, very, very important. So if suppose, let's say, we have an idea that for one lemon we need 2 glasses of water, right? So for one lemon, we need 2 glasses. So first one represents lemon, that is the top one. So I can't see this, is it? The first one represents the lemon, and second one represents the glasses.
Basically, 1 lemon by 2 glasses of water is proportional to
Right? Completed.
10 lemon by 20 glasses of water.
Correct. But can I write for 10 glasses of water?
EP, you can write 10 upon 10.
Wait. Can I write for 10 orange? For 10 orange?
EP, if you're using algebra,
can't.
then you can write x and upon 2x.
You could do that.
Yeah, you can do that.
This. My question is this a
Basic formula.
interesting?
Not at all.
Well,
Yeah, because this is a proportion for lemon juice. We are talking about lemon juice. We never came to orange juice. So when we are talking about lemon juice, only the concentration of lemon juice is going to be proportional. But we can't bring the
but ratio doesn't have this, no. Ratio, acha, that is ratio.
Units.
Yes. No, but
Yeah.
ratio also that happened only because of this, right? So for in this case we are talking about lemon, we are talking about ratio orange. So this is not a proportion.
Okay.
So I could also say what else is proportion. So let us say, okay, that means we are going to talk about lemons and glasses. So then can I write it as for every one lemon we need 2 glasses of water. Can I say that is proportional to say 2 glasses of water for 4 lemons? Is it silly?
Yeah. You can say that. No, you can't say that.
You can't.
Because
I said 2 glasses by 4 lemons.
so here you have less lemon compared to glass, but you are having here more glass compared to the lemons. So here it is going to be much sour than here. Okay, you won't be able to drink this lemon juice at all, or you can drink this lemon juice. Basically, in proportion, in whatever proportion you take, the taste should not change. In this case, the taste is going to change, right? So even this is not a proportion.
But EP, you know what happens if I make I double the proportion. I mean, like I double the ingredients in the same proportion of the cake, then the cake tastes bad.
Yeah, you could do that. Okay, you could do that. But when you are writing, so here it's like 2 glasses and 4 lemons. But if possible, you could have written 4 lemons for 8 glasses is fine. That is still a proportion, right? For 4 lemons, if you take 8 glasses, that is still a proportion, right? But here the case is exact opposite. For 2 glasses, you are having 4 lemons. Getting it? So the taste is going to change from this one to this one. Okay. So that means if you're talking about lemon and glass, in the second one also we're supposed to talk about lemon and glass only. We're not supposed to talk about something else. If we talk about something else, it's not going to be proportion. And even in the second one, yes.
Look, in the first one, it's 1 upon 2, which is equals to 10 upon 20. It's proportionate, no, proportional.
No, but we are talking about orange here, no? We're talking about orange here.
Yeah.
If you're not convinced with that, this example, here is lemon. This is lemon juice and this is orange juice. This is, we are telling, this is the key.
Now I understood. Yeah.
This is lemon juice and orange juice.
A different thing altogether.
What is it?
Basically, it's a different thing altogether.
Yes. So we just figure out this is not a proportion and this is not a proportion. Then what is proportion? Proportion is you have the same equivalent fraction. It should be an equivalent fraction in the first place. Here, even though they are an equivalent fraction, their units were different. It was lemon here, it was orange. But here, even though they were equivalent fraction, their things were interchanged. You had lemon in the top and glass in the bottom, actually you had glass in the top and lemon in the bottom. So whatever is there in the top, that should be in the top. Whatever is there in the bottom, that should be in the bottom. Okay?
Basically, 1:2 is proportional to 4. What am I saying? 2:4.
Four or four is three.
EP, my network is bad. It's showing network bandwidth low. Can I turn off my video, please?
You can do. So lemon glasses is equal to say 4/8 lemon glasses. So if you see, you have equivalent fraction. First check, lemon, lemon. Second check, glasses, glasses. Third check. So this is a proportion. The fraction which you are having should be equivalent. The units should be same. So this is a proportion. These are not proportion, but this is a proportion. Yeah? Can take it down. So we just saw in case of 1/2 lemon glasses is equal to 4/8 provided they are lemon glasses. These are proportional. But this is not the only way of denoting it. Okay, there is another way of representing it also. We said that 1/2 is in the ratio and 4/8 is in the same ratio, right? So we would say 1:2 is proportional to 4:8. So you use double dots over here. So 1:2 is proportional to 4:8. So the middle two terms are called means and the extreme two terms are called extremes. So can you do that? You multiply the extremes and multiply the means and tell me what do you answer. Multiply the mean.
8
The
is to
same
9.
answer.
Getting the same answer. If you multiply the extremes, product of extremes. Product of extremes. So that's going to be 1 into 8. And product of means,
Acha, like that.
yeah, product of means is 2 into 4. So 1 into 8 is 8, 2 into 4 is also 8. So the product of means is equal to product of extremes. So using this, we might actually be able to solve many word problems. As I was telling, from what we know, we can determine what we don't know. Like, let's just take an example. Let's say PR is able to read 3 books in 4 days. So it's like books over days. Okay? If she is able to read 3 books in 4 days, how many books will she be able to read in say 24 days? So don't get the answer yet. Let's just express it in proportion first. So 3:4. 3:4 is proportional. It's proportional. X is to 24. You should not change the order. Because if we change the order, then the order of means and extremes will be discussed. So yeah. So we know that product of means is equal to product of extremes. So what is product of extremes here?
EP, I can't
X is
see your
15.
thing clearly. What is 3? 3?
3:4.
X is 18, no.
No, what is the example called?
Books, X books.
And dogs.
No, days.
Days. Books and dogs.
Days. Arey, I can't see अच्छे से. That's why I wrote dogs.
Product of these. Okay. So tell me, product of extremes, the two things which is on the extreme side is 3 and 24. So you have 3 and 24. And we know product
The value of x.
of mean. And product of mean is 4 into x. So if you see this particular question,
3 and 2.
yeah, what is
It's
18?
It's
18.
18, yaar. Kab
18.
se?
So easy.
Yeah.
4 6 are 24, 3 6 are 18.
Or you could bring, what is 3 into 24? You're not doing that. is
What?
it?
3 into. No, I did something
No,
else.
what I did was I
You just divide 24
saw,
by 4.
yeah, and then whatever it is, I multiplied it 3.
You transfer that here, this is in multiplication, so this comes to
Yeah,
division.
transposition. Correct.
Yeah, but in mind.
3 into 24 upon 4 is equal to x. So 4 and 24 gets cancelled. 6 4s are 24. So this implies x is equal to 3 into 6, 6 3s are 18. So she reads 18 books. Make sure you just don't write 18, but write down 18 books. Because that is what she's doing. She's not eating 18 pizza, but she's reading 18 books in 24 days. Okay? Yeah.
Yeah.
So in last class we discussed about golden ratio. Okay, golden ratio or golden rectangle. We're talking about golden rectangle. So we concluded or we saw that any rectangle which is possessing the property, let's say this is a rectangle, the longer length is A and the shorter length is B. So the rectangle which is possessing the property of A plus B upon A is equal to A by B. So if you see, this is one ratio and this is another ratio, but we are equating these two ratios. So actually, this and this is in proportion, right? So we can actually say A plus B, which is in ratio with A, is proportional to A is to B. So this entire thing, whatever we learned in last class, was actually proportional. Yeah, and that entire thing, not every rectangle possesses this particular property. Only the golden rectangle possesses, and this value is exactly equal to an irrational number. So irrational number means a number with something which goes on forever without any particular factor. So it's like 1.618 and so on. So this number doesn't actually have any pattern. But so we can't actually write a number everywhere, right? So this particular number needs a representation, and that representation is a 5. It's a 5 symbol. So this is golden ratio. That 5 is golden ratio.
Wait,
What sign?
What is that? Pi.
What is that?
No, not 5. 5 is
It's golden ratio.
this is 5.
I is like the musical sign.
PHI. This is spelled as PHI.
Pi.
5.
Acha.
This is just PI.
Yeah.
This is spelled as PHI of 5. Yeah? So now we have a map over here. So this is a map of where we are now, Sahyadri schools. We have Kotalwadi, Darakpadi, all these places right next to everything. So my question is, look at this number over here. Okay? When I'm trying to magnify, number is reducing. When I'm trying to come out, 1 meter, 1 kilometer, 2 kilometer,
Yeah.
kilometer, 5 kilometer. What do they actually mean by this? Tell me.
You're zooming
Each
out.
unit equals to 5 kilometer. Each
Yeah.
centimeter equals to 5 kilometer. Each
Yeah.
inch equals to 5 kilometer. Some unit equals to 5 kilometer.
EPI studied architecture में
scale.
this thing, it's called
It's
the
a
ratio, the
scale.
scale. If you're building a
Yeah.
house and you make a small model, there's a scale that you use to measure the house,
Yeah.
and then you
Like,
ratio करके you put it in the small model. So that's the scale, you taught the scale, na?
So basically,
Yeah.
now if you see, you can see this 2 kilometer thing, right? I hope all of you can see this 2 kilometer thing. So yeah, so this particular thing over here, this line over here, this line represents 2 kilometer. It's a very small scale. This represents 2 kilometer. if I'm trying to bring that Betale and Mohakal, okay, if you see the distance between Betale and Mohakal is approximately 2 kilometers. Can you see this? So this and
Where is Bitale and Mohoi Dhawal?
Betale is here,
Found it.
Mohakal is here.
Yeah.
This distance is 2 kilometers. If you see here, when they come, they're almost, the difference is little more than 2 kilometers. Are you able to see that?
Yes.
Yeah.
So, without actually going there and measuring, like you need not have a tape and you need not stand in Vitale and go to Mohakal and see the distance. You can actually see in this itself. You know this is 2 kilometers. Measuring it with scale and measuring the scale with this, you can actually find it out. Let's just find it out. So, how much do you think it's more? It's like 2 point, that is 2 kilometers. Let's say it is like 2.3 kilometers. Okay, let's say it is 2.3 kilometers.
Just zoom in a bit. Not a bit, like a lot. Yeah, that's it. That's it.
Yeah, let me just do.
Now as Butale and Mohakal.
Yeah,
Huh.
they are much more farther. So here they are 500 meter. So this is going to be the second 500 meter. Third,
Got it.
yeah, almost. So
Got
yeah,
it.
one of you can take this up as a project and explain us on this much more.